Hello students, welcome back to my YouTube channel Sidhu Mathematics. In the last video, we have learnt formulas of trigonometry, isn't it? Of course. In this video, we are going to learn a very simple and easy trick to remember all formulas of trigonometric functions. Now consider a hexagon. What is hexagon? Hexagon is a figure that has 6 sides and 6 vertices. 1, 2, 3, 4, 5, 6. 6 sides and 6 vertices. 1, 2, 3, 4, 5 and 6. And the vertices contain trigonometric functions. Those are tan, sine, cos, cot, cosec and sec. These are the 6 trigonometric functions, and the most important thing that is to remember is the positions of the trigonometric functions are going to be fixed. This is my humble request. Please remember the positions of the trigonometric functions. These are going to be always fixed. Okay, please watch this video till end. I will tell you about 40 formulas. In this video, we are going to learn reciprocal formulas, second one is ratio formulas, third one is product formulas, fourth one is square formula, fifth one is complementary formulas, and the sixth one is identity formula. First, I will tell you about reciprocal formula. In this, when I draw the diagonal, I am connecting two functions. It means when I draw diagonal, I am connecting two functions. These two functions will be reciprocal to each other. Now let me explain you by joining the two functions, that is by diagonal. I will join sine and cosec. I will join tan and cot, and I will join cos and sec. Sine will be reciprocal of cosec, and similarly cosec will be reciprocal of sine. Here tan will be reciprocal of cot and cot will be reciprocal of tan. Here sec will be reciprocal of cos and cos will be reciprocal of sec. In this way, this happens only when diagonals are connected. It means along the diagonals the functions will be reciprocal to each other. First one is, it can be written as sine is reciprocal of cosec. Second one, similarly cosec is also reciprocal of sine. Third one is tan is reciprocal of what? Cot. And fourth one is similarly cot is reciprocal of tan. Fifth one is cos is reciprocal of sec and sec is reciprocal of cos. And sec is reciprocal of cos. In this way, please remember this trick. Along the diagonals, we should go along the diagonals for reciprocal relation. Next comes the ratio formulas. Now going in the clockwise direction, that is in this way. Going in the clockwise direction starting from tan. Starting from tan. Starting from tan, tan is equal to ratio of sine by cos. In the same way, sine is equal to ratio of cos and cot. Again, cos is equal to ratio of cot and cosec. Again, in the same way, cot is equal to ratio of cosec and sec. And next term, the cosec is the ratio of sec and tan. Again, sec is the ratio of tan and sine. When we go in the clockwise direction, we get these ratios. Okay, when we come in the anti-clockwise direction, there are some other ratios. That is, when we come in anti-clockwise direction, the functions we get is starting from tan. What we will get? Tan is equal to ratio of sec and cosec, isn't it? Of course, sec is the ratio of cosec and cot. Next, sec is over. Next, cosec. Cosec is the ratio of cot and cos, of course. Next comes the cot. Cot is the ratio of cos and sine. Similarly, cos is the ratio of sine and tan, and sine is the ratio of tan and sec. Please remember, this is by clockwise direction and this is by anti-clockwise directions. These ratios we get. Now let us come to the square formula. In square formula, we have to consider three shaded triangles, that is these three triangles and one at the center. Okay, in square formula what happens is, in a triangle there are three vertices. The sum of squares of two vertices is equal to square of the third one. Let me explain you. In square formula, what all we have? Three shaded triangles we have. The function is sum of squares of two vertices is equal to square of third vertex. Consider the three triangles, triangle 1, triangle 2 and triangle 3. Okay, sum of the squares of two vertices, that is come in this direction, come in this direction, come in this direction. Square of sine plus square of cos is equal to square of 1, that is sine square plus cos square is equal to 1 square is nothing but 1. Now first triangle is over. Next come to this triangle, that is tan square plus 1 square is equal to sec square. 1 square is equal to sec square. And the third, come to the third triangle, 1 square, that is nothing but 1, plus cot square is equal to cosec square. Once again, sum of the squares of two vertices is equal to square of the third vertex. We have three triangles. This is square formula. Next comes the product formula. In product formula, what happens is the product of two functions is equal to function between them, that is product of sine and sec is equal to tan function, product of tan and cos is equal to sine function, product of sine and cot is equal to cos function, product of cos and cosec is equal to cot function, product of cot and sec is equal to cosec function, product of sec and sine is equal to tan function. Product of two functions is equal to function between them, that is first one is sec into sine is equal to tan, next one is tan into cos is equal to sine, third one is sine into cot is equal to cos, next one is cos into cosec is equal to cot, next one is cot into sec is equal to cosec, next one is cosec into tan is equal to sec. These are the product formulas. Once again, let us revise. Product of two functions is equal to function between them. Product of two functions is equal to function between them. Product of two functions is equal to function between them. Similarly, now next comes the complementary angles. For complementary angles in the hexagon, these three lines are very important. Okay, line 1, line 2 and line 3. In first line there are two functions, sine and cos. Sine theta is equal to cos of 90 degree minus theta. Similarly, cos theta is equal to sine of 90 degree minus theta. These two functions are complementary to each other. Similarly, come to the next line, that is having functions tan and cot. Tan theta is equal to cot of 90 minus theta and cot theta is equal to tan of 90 minus theta. These both are complementary to each other. Tan theta is equal to cot of 90 minus theta. Similarly, cot theta is equal to tan of 90 degree minus theta. Now come to the third line. The two functions are sec and cosec. Even these both are complementary to each other. That is, sec theta is equal to cosec of 90 degree minus theta. Similarly, cosec theta is equal to sec of 90 degree minus theta. Once again, the important thing is, for complementary angles, these three lines are very important. Next comes the identity formula. Identity formula. For identity formula, these diagonals are important. That is, diagonals of hexagon are important. Now, in the first diagonal, we have two functions, tan and cot. The product of tan function and cot function is equal to 1. Similarly, in the next diagonal, we have two functions, sine and cosec. The product of sine function and cosec function is equal to 1. Next, come to the third diagonal. We have two functions, sec and cos. The product of cos and sec is equal to 1. These are the identity formulas, that are tan into cot is equal to 1 and sec into cos is equal to 1. Similarly, sine into cosec is equal to 1. Thank you for watching the video, guys. Please practice this hexagon, that is super hexagon, for 3 to 4 times. You will be perfect, and this is going to help for exams very much. Even though if you forget the formulas, you can find your own.
Thank you students for watching my video. Please like, share and subscribe my YouTube channel. Thank you.